In this section, we'll take our spatial analysis further by creating buffers around the streams and quantifying the amount of land use within the buffer area. Imagine we're interested in protecting our streams and we want to know what kinds of land use are along them. Okay, you should already have your land cover drawing in your current project. If you don't, you can load it now or load the sample land cover drawing that's in the data directory. You should also have the Legend.xml file that will allow you to thematically shade the map. Now I'm going to just double check and make sure that my map is in the right projection, UTM 18 NAD 27. If you don't have a projection, assign one now. The next thing I've done here is just create another map component, and I'm going to drop the land drawing inside it. Under File, Import, I want to import the hydrology file, and this is an ESRI export file. So under the file type, I'm going to put E00 and select U27HYA. Just takes a second to load, and let's drop that component, the ARC drawing, which is the ARC file, into the map. And here you can see that the hydrology is on top of the land cover. Okay, before we perform our buffer, we should quantify the land use by creating a query. Here I've created a query component, and I'm going to type in some SQL code. In this case, we know that the land cover type field is LC, so I'm going to say select LC, and I also want to select the sum of all the area. So I'm going to use the area intrinsic value. That's why we put the parentheses with the I in it. And I'm going to divide that by another select statement where I select all the area from the entire land drawing. So what I'm basically doing is I'm trying to get the total area for each individual land cover divided by the total area for the entire drawing. So here I'm going to select the sum of all the area from land. And I'm going to multiply that by 100. That gives me a percent. I'm going to also group each of the records by the land cover. Now one thing I've got to do is change this land drawing to land, because I just called it land in my query. So I'll type land. And now I'll execute it. And here you can see the results of the query. For instance, forest is about 56%, about 30% is agriculture, another 10% is developed, water is about 1.5%. Okay, we have a little more hydrology there than we really need. Now first I'm going to right click on hydro in the project pane and rename it. I'm going to call it hydro. It's going to make things a little easier when we write our query. So the first thing I want to do in the transform tool is select all the objects in hydro and clip it with the boundary of land. So I want to get rid of all those other hydrology records that are outside. When I hit apply, you can see they all disappear. So now all of our hydrology has been clipped to the border of the land. Now we're going to buffer the hydrology. So here I'm going to create a new drawing, and I'm going to call it strbuff. We're going to throw our buffer into this drawing. Now using the transform tool, let's first make sure that the stream buff is the active component. And in the transform toolbar, let's buffer all the objects in hydro by 100 meters. I'll hit apply, and it'll just take a few seconds in order to complete. And what we want to then do is quantify all of the area of the land cover that falls within that buffer. Okay, you can see our buffer's been created for all the hydrology. The next thing we want to do under drawing is go to topological overlay. We want to intersect this buffer with the land cover. So I'm going to perform a topological intersection between the hydro and the land and the stream buffer. Between the land and the stream buffer. When I hit OK, it'll take, again, just a couple of seconds to perform the intersection. And here you can see we've created a new component called Land2. I'm going to double click on that and open it, and you can see here this is the intersection of the buffer and the land cover, and you can see we have land cover values as well as information about the stream buffer in each polygon. And I'm going to rename this D2 just to make things easier for my query. Now to requantify the land cover, let's go back to the query we wrote before. And we're going to select, instead of land, now we're going to use D2. So it's the same query, but we're now performing it on the D2 component. And here you can see we've completed the quantifying of the land cover based upon the stream buffer.